Okay, on the next set of problems, we're just going to be dealing with factoring and seeing some examples of some of the problems that we could potentially have. Of course, there's more than just these types of problems, but we will see a lot of them that we've done tests on. So make sure you review your tests as well and go through them. So the first one is just factoring, straight factoring. So we have a difference of squares. So that is x plus 4 x minus 4. So make sure you remember the difference of squares. Remember that both have to be perfect squares when we're doing that. I'm going to throw in one other example. So let's say that I have 9x squared minus 64. Notice that every single one of those is a perfect square. So that would be 3x minus 8 and 3x plus 8. So that's what we have when we do those. On these problems down here, notice that this is not a perfect square. This is, and this is, but this is not. So all of them have to be perfect squares. If they aren't, then you have to find a common factor if possible. Notice that both of them have a 5 that go into them. Both of them have an x. And then what's left over is just an x and a minus 5. So that would be 5x times x minus 5. On the next one, we have x squared minus 4x minus 60. So there we have, notice that we don't have a number there other than 1. So that's an implied 1 there. So I just go right to negative 60 in my table. I am going to notice here that the first minus, the one with the 60s, tells me that 1 is positive, 1 is negative. And this minus tells me that the larger one is negative. So I'm going to go ahead and draw a few just to kind of get there. So I have 1 and 60. Obviously, those don't add up to 4. I have 2 and 30, still don't. 3 and 20, still don't. 4 and 15, still don't. 5 and 12, still don't. 6 and 10, there we go. Those two add up to negative 4. Because of that 1 in front, I can factor it directly. So I have x plus 6 times x minus 10. Okay, so now we get into a more difficult one. Now notice that these two problems are kind of combined in a sense. So I'm going to go ahead and I'm going to factor this one. And the way that I would factor it is I would multiply 6 times negative 3. That equals negative 18. First off, when I'm going through and looking at that negative 18, I'm going to notice that this is telling me that they are both different. And this one tells me that the larger one is negative. So I have 1 and 18, 1 and 9. I have 1 and 9, 2 and 9. I should learn how to add there and multiply. So these two add up to negative 7. So I'm going to use those. However, I have a number in front. When I have a number in front, I have to go directly to the box method. So I'm going to put in my 6x squared, which comes from here. I'm going to put in my negative 3, which comes from here. And then I'm going to put these two numbers in the other boxes. So I'm going to have 2x and negative 9x. And it does not matter where they go. The only thing that's important is that these diagonals have to add up to negative 7x, which they do. Okay, so we can see that. So now we look at the first column. The first column would be these two numbers here. So what's common to those? I can see that a 2 goes into both of them and an x goes into both of them. I'm then going to look at this column here. We look at the 9 and the 3, and of course 3 goes into both of them. Then I see this negative at the top of the column, so that means it has to be negative. I go across. What's common between 6 and 9? That would be a 3 and an x. And then what's common between a 2x and a minus 3? Well, nothing is, so we just put a 1 there. And notice that the first number in the row does not have a negative, so therefore that's not a negative. So this factors, and I can write it for the second one, but this one factors down to 2x minus 3 times 3x plus 1. Okay, so now on this problem I can rewrite it. So I'll do 2x minus 3 times 3x plus 1, all divided by, and now you notice that this is also a difference of squares. So that would be 2x minus 3 and 2x plus 3. These cancel because they're exactly the same. These do not, so my final answer would be 3x plus 1 divided by 2x plus 3. Nothing can cancel there. Even if there were any of the same numbers, we couldn't cancel anything there because remember the plus sign does not allow us to do that cancellation. And that is the last problem on exit ticket number 2.